Hello viewers, welcome back. In this video, we are going to be learning STP, stands for Spanning Tree Protocol. The Spanning Tree Protocol is a loop prevention protocol is used to prevent layer 2 loops. For example, here we are seeing a loop here. Let's pretend the fast Ethernet 0/1 is up. Okay, so for example, now the switch 2 is sending a broadcast traffic. So the switch 1 and switch 0 will receive the traffic. Now the switch 1 and switch 0 will forward the broadcast traffic. Again, the switch 1 receives the broadcast traffic and forwards. Now again, the switch 2 receives the broadcast traffic and forwards. Switch 0 receives this broadcast traffic and forwards. So now your broadcast storm is created. So this may cause a big problem. This may take the network down. Okay, so the broadcast traffic has been created. Then, for example, an unstable MAC address. Okay, so unstable MAC address. Now, the switch one sending the broadcast traffic with the MAC address AA. So now switch one will update its MAC address AA with fast Ethernet 0/1. Again, switch two sends the packet and traffic, and switch 0 forwards the traffic. Again, switch 1 receives AA from Giga Ethernet 0/1 and it will update the MAC address. Okay, so now the MAC address becomes unstable. Okay, so next one, they will create duplicate frames. For example, here there is a PC over here, it's connected. Now the broadcast traffic is forwarded to the destination. Now the PC already received that broadcast traffic. Again, the switch 0 receives the same broadcast traffic. Again, it forwards the traffic to the PC. Now the PC will drop the frame because this frame is already received by the PC. So it creates duplicate frames. So to prevent these problems, issues, we are using STP. So what the STP will do is it will block one of the ports. So now, for example, here you can see fast Ethernet 0/1 is blocking because by default Cisco on all Cisco switches STP is enabled. So by default STP is enabled. So here you can see fast Ethernet 0/1 is blocking. So the challenge is which port should be blocked and which port should not be blocked. So that's the big challenge. So this challenge is accepted by the STP protocol. So the STP protocol will decide which port should be blocked and which port should not be blocked. So the first step is in STP is to elect a root bridge. So the root bridge is nothing but one of the three switches will become a root bridge. So all the ports on the root bridge will become designated ports. So they always forward traffic. Okay, so the root bridge will always forward traffic, and all the ports on the root bridge are always up and running and forwarding traffic. So here, let me show you. Enable show spanning tree. Here you can see this bridge is the root bridge. The reason is the priority is 32769 and the bridge ID is 00 starting with 0002. The bridge ID is nothing but the MAC address. So the MAC address of the switch. Now let's go to switch 0. Enable show spanning tree. Here you can see the bridge ID and the priority. Priority is 32769 and the bridge MAC address is 0040. I have already updated the details over here. You can see. Then enable shows spanning tree. So the bridge ID, so the priority 32769 and the MAC address 00 starting with 0060. So here you can see 0060, 0040 and 0002. So first step is to elect the root bridge. So now we are going to elect the root bridge. First priority. So based on priority, now switch 1, switch 2, and switch 0 have the same priority. So the lowest priority will become the root bridge, but here all the switches have the same priority. So the match is tie here. Next, based on MAC address. So if the priority value is tie, next based on MAC address. So the lowest MAC address will become the root bridge. Here 0, 0, 0, 3 zeros. Here 2, 0, then 4. Here 2, 0, 6. So which is the lowest? Yes, it's none other than switch 1. So he is the root bridge because he has the lowest MAC address. So he becomes the root bridge. So he's the root. Okay, so he's the root bridge. Now each non-root bridge has to select the root port. So the root port is nothing but it is the shortest path to reach root bridge. So it is the shortest path to reach root bridge. So each non-root bridge. So switch 2 and switch 3, sorry, switch 0 have to select the root port. Okay, so they have to select the root port based on cost. So this selection is based on cost. So the lowest cost wins the election. So here fast Ethernet, sorry, Giga Ethernet is 0/1, the cost of 4, and the Giga Ethernet 0/2, the cost of 4 plus 19. So the switch 0 has two ways, so two paths to reach the root bridge. The first path is Giga Ethernet 0/1 and the cost of 4, and the second path is Giga Ethernet 0/2, the cost of 4 plus 19. 4 plus 19. So who wins the election? Giga Ethernet 0/1. Here you can see Giga Ethernet 0/1 becomes the root port and it is forwarding. So fast Ethernet, Giga Ethernet 0/1 becomes the root bridge. Now on switch 2, so now on switch 2, okay, now on switch 2. So there's two paths to reach the root bridge. Here the cost of 19, here the cost of 4 plus 4, 8. So which is the shortest path? Giga Ethernet 0/1. So Giga Ethernet 0/1. Let me show you. Here Giga Ethernet 0/1 becomes the root port because the cost is 8. Then fast Ethernet 0/1 is alternative and blocking. Let me show you why the fast Ethernet 0/ is blocking. So now the balance ports are Giga Ethernet 0/2 and fast Ethernet 0/1. Now they have to decide who is going to block this. Okay, so fast Ethernet 0/1 or Giga Ethernet 0/2. So this election is based on priority and MAC address. So the lowest priority, or if there is a tie, then the lowest MAC address. So here both switch 2 and switch 0 have the same priority value. Then let's go with MAC address. So here switch 0 wins the election and Giga Ethernet 0/2 becomes the designated port because it has the lowest MAC address 004, here 006. So fast Ethernet 0/1 is blocking. Okay, so this is how the spanning tree is working. So let me show you another thing. Now let's connect this with Giga Ethernet. Giga Ethernet. Let's see who is going to block the cost of 4. He is the root bridge. Okay, so he's the root bridge. So all the ports on the root bridge are active and forwarding traffic. Okay, so Giga Ethernet 0/2 will be the designated port and it will forward. Here you can see the green light. So now here you can see this port is blocking. Who is blocking? Giga Ethernet 0/1 is blocking. Let me show you. Show spanning tree. Here you can see Giga Ethernet 0/1 is blocking because now the switch 2 has to select the root bridge. Okay, so the root port has to select the root port, and the root port election is based on cost. Okay, so cost based on cost. So here the cost of 4, here the cost of 4 plus 4. So the cost of 4, the cost of 8, 4 plus 4, 8. So who wins the election? Giga Ethernet 0/2 wins the election, and it becomes the root port. Okay, so the root port election is based on cost. Okay, so now switch 0 also has to select the root port. Here the cost of 4 and the cost of 8, and Giga Ethernet 0/1 wins the election, and it becomes the root port. Let me show you. Show spanning tree, and Giga Ethernet 0/1 becomes a root port because it has the lowest cost to the root bridge. And now Giga Ethernet 0/2, and here also Giga Ethernet 0/2, and switch 0 and switch 2. So someone has to block. Okay, so someone has to block. So who is going to block here? Switch 2, because it has the highest MAC address, okay, value. So he is forwarding because he has the lowest MAC address 004, here 006. So he is forwarding, he is blocking. Okay, so this is how it is working. Now let's see. What I'm going to do here is I'm going to connect another port. Okay, so let me connect first Ethernet 0/1 and first Ethernet 0/1. Let's see who is blocking and who is forwarding. Here you can see. So this is the root bridge. So all the ports on the root bridge are become designated ports, and they are forwarding traffic. Now let's go to switch 2. Let's see, Giga Ethernet 0/1 is blocking. Giga Ethernet 0/2 is the root port, and fast Ethernet 0/ is blocking. Okay, so the reason is, so Giga Ethernet 0/1 is the root port because it has the lowest cost, the cost of 4. I think Giga Ethernet 0/2, yeah, Giga Ethernet 0/2 is the root port, and it is forwarding traffic because it has the lowest cost. And Giga Ethernet 0/2 is also blocking because of the MAC address they have. Now fast Ethernet 0/1 is blocking. Here, let me show you. You can see the MAC address 0002 and 0006. So it is the lowest one. So switch 2 has to block. Okay, so switch 2 has 2 directly connected ports to the root bridge. Okay, and the cost of the each port is the cost of 4 for Giga Ethernet and the cost of 19 for fast Ethernet. And here Giga Ethernet wins the election. Okay, so cost of 4, and he becomes the root bridge, and the other port, the non-root ports, has to decide whether the blocking or forwarding. Here root bridge always wins, so switch 2 has to block. So let me show you. Instead of connecting to Giga Ethernet, I'm going to connect fast Ethernet. Okay, so now the both ports are fast Ethernets. Okay, so both are fast Ethernet. So the cost of 19. So the cost of 19. Let's see who is blocking and who is forwarding. Let's see who is blocking and who is forwarding. We are waiting. So it is the root bridge, and all the ports on the root bridge are designated ports, and they are forwarding traffic. Here you can see all the ports here are designated ports, and they are forwarding traffic. Connect to STP 0/2. Here you can see all the ports are designated ports and forwarding. First Ethernet 0/2 is listening. Now let's wait. Now still listening. So it will go up to 50 seconds. Okay, 15 seconds. So 15 seconds listening. Yeah, now it's forwarding. So 15 after 15 seconds of listening, now the port is forwarding. Okay, so now the both ports are blocking. The both ports are blocking because the root port is Giga Ethernet 0/1 because the cost of 4 plus 4 8. But here the ports, so here who wins the election? Switch 0 because of a MAC address 004. Here 006. So your switch 0 is forwarding and switch 2 is blocking. Okay, so here the based on MAC address, they are making decisions, okay, based on MAC address. So the hello timer is 2 seconds. So every 2 seconds they will exchange hello message, and the max age is 20 seconds. For example, now I'm going to disconnect one of the ports. Okay, so now this port is disconnected. Okay, now 2 seconds, so 20 seconds. So let's wait for 20 seconds of max age and the 15 seconds of listening and 15 seconds for forwarding. So totally 50 seconds we have to wait. We have to wait for 50 seconds. Okay, now this port is forwarding. After 50 seconds, this port is forwarding. So 20 seconds of max age. So now this is not forwarding, it is listening. Let me show you. Okay, let me show you. Okay, let me connect this. Now it becomes a blocking because I connected the port. Okay, let's wait for another 20 seconds, max age. So 20 seconds. 20 seconds. So 20 seconds, now it's learning. So it's learning MAC address. Now it's forwarding. Okay. So 2 seconds for hello, 20 seconds for max age, and 15 seconds for forward delay. So totally 50 seconds you have to wait. Okay. Okay, let's say instead of disconnecting, I'm going to block 0/2 /2 and say shut. Okay, let's wait. How long will it take? Waiting. Waiting. Still blocking. Fast Ethernet 0/1 becomes the root bridge and it is forwarding. So you can see learning, then forwarding. Okay, let's go to, okay, I'm going to block Fast Ethernet 0/1. Okay, let me shut down. Okay, let's wait. Here you can see listening state, then still listening, still now learning, still learning, 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 now forwarding. So it takes around 30 seconds something. So now max age 20 seconds plus learning plus learning state 15 seconds. Now it is forwarding. So think around 35 seconds. So this is how STP is working. And thanks for watching the video. And if you have any doubts, please drop your questions in the comment section. There I'll be answering your questions. And thank you